The objective of this lesson is to rewrite a multiplication equation involving a non-unit fraction multiplied by a whole number into an equivalent multiplication equation with a unit fraction multiplied by a whole number. In the previous lesson, students learned how to identify fraction multiples on a number line. In this lesson, students will be formally introduced to the algorithm of multiplying a fraction by a whole number, moving students away from using repeated addition. Using repeated addition to solve multiplication problems will eventually hinder students' ability to solve more complex problems and when the factors increase in size. Using the fraction multiple sheet, let's show 3 multiples of 3/4. How can we record this as a multiplication equation? We have 3 groups of 3/4, so this model shows 3 times 3/4 equals 9/4. Now let's take this model and move the shaded squares to show a new model where each whole has only one shaded square. Are the number of shaded squares still the same in the second model? Yes. How would we write the multiplication equation for this model? Since there is only one shaded square in each whole, the shaded part represents 1/4. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 1/4 units, or 9 times 1/4 equals 9/4. Let's take our first problem of 3 times 3/4 and model it on a number line. We make one jump of 3/4, another jump of 3/4, and another jump of 3/4, which gets us to 1, 2, 3, 4, 5, 6, 7, 8, 9/4. 3 times 3/4 is the same as 3 groups of 3/4. Each 3/4 is made up of 3 groups of 1/4, so we can also think of this as 3 times 3/4, or 9 groups of 1/4, or 9/4. Now let's take our second problem of 9 times 1/4 and model it on a number line. We make 9 jumps of 1/4, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4. 9 times 1/4 is the same as 9 groups of 1/4. We could also think of this as 9 times 1/4 or 9/4. When we look at the two examples, what do you notice? Do you see a pattern? It looks like the whole number or number of jumps and the numerator are multiplied together, and the denominator stays the same. Students will continue to find equivalent multiplication equations with a whole number and non-unit fraction and draw a model either with grid paper or a number line to justify their equations. The objective of this lesson was to rewrite a multiplication equation involving a non-unit fraction multiplied by a whole number into an equivalent multiplication equation with a unit fraction multiplied by a whole number. We met this objective by using pictorial area models and number lines and having students write the equivalent fraction multiplication equations to represent their various models.